let's say you have two best friends, and best friend number 2 isn't always as reliable as best friend number 1. The same concept applies to the second derivative test. This is true because the second derivative test doesn't always work. Nevertheless, the second derivative test is still a method to find the extrema of a function in lieu of the first derivative test. Extrema are your local max and minimum values of a function.
Here we've drawn the graph f of x equals cosine of x. Now the range for cosine of x and sine of x is -1 to 1. There is a local maximum value at 0, 1, which is the tallest point in the area. Now keep in mind, local maximum values are not absolute maximum values. We also have a local minimum value at pi -1. Now when to use the second derivative test, you might ask. Why use the second derivative test at all if we can just use the first derivative test to find extrema of a function? Well, we can always use the first derivative test to find extrema, but the second derivative test is an alternative method that has certain perks. For example, it's more efficient if the second derivative is relatively easy to find. Like in f of x equals x squared minus 4, f prime of x, or the derivative, is just 2x. It also prevents us from using a sign chart, as sometimes it can be very tedious, but only if f double prime of x is not equal to 0. So next we're going to actually demonstrate the process of the second derivative test, which is split into two parts. Part 1 is to differentiate the function or find the first derivative. After this, if possible, you want to factor the first derivative, after which you'll set the derivative equal to 0 and solve for x. These solutions, or x values, are called critical points. Critical points have two criteria. The critical point must be in the domain of the function, and the critical point has to make f prime of x equal to 0 or f prime of x equal undefined.
For part 2 of how to perform the second derivative test, you must first differentiate the function f prime of x to find the second derivative, f double prime of x. Then, you plug in critical values into the second derivative. The solutions you get are your extrema. If f double prime of c is less than 0, then there is a local max at x equals c. If f double prime of c is greater than 0, then there is a local min at x equals c. And if f double prime of c is equal to 0, the test is inconclusive and you must go back to using your first derivative test. So here is an example of when you can use the second derivative test successfully to find the local max and min of a function. Here we have the function x to the 4th minus 2x squared plus 3. First, we're going to take the derivative of f of x. From that, we're going to get f prime of x is equal to 4x cubed minus 4x. Next, we're going to find the critical values of f prime of x. In order to do that, we factored the function, and then we got 0, 1, and -1. Next, we take the second derivative. The second derivative of f of x, f double prime of x, is equal to 12x squared minus 4. Finally, we're going to plug our critical values into our second derivative. From that, we get f double prime of 0 is equal to -4, f double prime of 1 is equal to 8, and f double prime of -1 is equal to 8. Thus, we have a local max at x equals 0, a local min at x equals 1, and another local min at x equals -1.
Here we have an example that doesn't quite work with the second derivative test. F of x equals x to the 4th power minus 4x to the 3rd power. F prime of x equals 4x to the 3rd power minus 12x to the 2nd power. We factor this derivative into 4x to the 3rd power times x minus 3, and then we set it equal to 0. We get the critical values x equals 0 and x equals 3. We then find the second derivative, f double prime of x equals 12x to the 2nd power minus 24x. So f double prime of 0 equals 0, and f double prime of 3 equals 36. We just plugged in the critical points to the second derivative. However, we get f double prime of 0 equals 0, so the second derivative test is inconclusive. At this point, we know we must go back to the first derivative test. When we do the first derivative test, from the sign chart we can conclude that the local max is x equals 0 and the local min is x equals 3.